Hi everyone, James and Matt's are both sick today, so I'll be the one taking over Lecture 8 RSA Encryption and exercises. Let's start with what is RSA. RSA is a method for sending secret messages using math-based keys, a public key to lock, encrypt, and a private key to unlock, decrypt. So what do you need to know? We'll go through 7 simple steps. First, we'll choose two prime numbers that you only divide by 1 and themselves. Multiply them to get an n number used in both cases. Calculate e number using this formula. Choose e, choose d, and encrypt the message using, again, formula, and decrypt using a formula. I don't show you the formula right now because it will be a little too difficult to understand if you're not familiar with encryption. Therefore, we save it to the end. For those who are not familiar with prime numbers, here's a very nice quick explanation. Prime number is a number that can be divided evenly by anything except 1 and themselves. Examples are 2, 3, 5, 7, 11, 13. Let's take 4. 4 is not a prime number as it is divided both by itself by 1 and also by 2, so it's not a prime number. In our case, we will be choosing two prime numbers. The first, we just choose them randomly. The one is 5, which we call P, and then there's Q, 11. In order to get an n number that will be using both keys multiplied by two prime numbers, 5 and 11, and we get 55, it is part of both keys. Step number 2, calculate P number. The formula is to take the first P number, 5 minus 1, multiplied by 11 minus 1, which is 4, multiplied by 10, which is 40. Step number 4, pick a public number E, which we'll be using to encrypt. In order to pick a number E, we'll have to cover following conditions. First, number E must be less than phi. Our phi is 40, and it shouldn't be a factor of phi, so they're co-prime. Based on those, we choose number 3. Our public lock now is E, n, which is 355. This formula that you see here is the formula for finding a private number D. And the private number D is basically reverse of E. I'll explain what it means. We have an E, which is 3, which you already know here. What D do we need so that this formula holds? And for this case, we're just choosing 27, just out of nowhere, kinda, and then we do the following. So now we have 3 multiplied by 27 is 89. Take 81 modular phi, which is, okay, this can be simplified to just 1. Okay, it doesn't want us to, but it's 1. So therefore, the private key is D. And now let's try the step number 6. We will encrypt a message. We are encrypting message, which is quite simple. It's just four letters. Now we need this little table, letters in alphabet order from 1 to 26. We'll be using it to turn letters into numbers. We can just copy paste it here. So S, as you can see here, is 19. A, 1. Just keep in mind, we don't just type 1. Just type 01. And then we have L, which is 12. And again, A, which is 01. So that we encrypt or kind of hide each number. And we're doing this with this formula. The first one is the formula to encrypt our message. And the original is for the let's start with our encryption. Let me just paste it here and then I'll explain. As you can see, we take every number or like every letter, we put it up in 3 because this is our encryption number. And then modulo n. That's why we needed all these numbers. But let me just explain quite quickly what it just modulo means. So modulo or just mod means what's the remainder when you divide one number by another. Just a quick example. Assume we have a mod b. So what does it mean? It means divide a by d. No, by b. And the result is the remainder like this. This is how simple it is. Let's take a quick example. 10 modulo 3, which is 1, obviously, but how do we get it? So when we think about 10, how many times do we need to multiply 3 by so that we're going to get 10? Actually, it's simple because it's obviously 10. So we multiply 3 by 3 and the result is 9. We use the result we get to get a remainder. So our remainder will be following 10 minus 9, which is 1. Boom. So this is the modulo, how modulo works. Just another example in case if it's not quite clear. We're taking it like this. So what do we do to multiply number 5 by what number? So we're gonna take 19s. Like 5 by 2 is 10, 5 by 3 is 15, and this is a close so far. 5 by 4 is 20. It's too much. So we just use 5 by 3. It's 19 minus 15, which is 4. That's how it is. We can just put this over here. So this is what we do. So 19 by 19 by 19 modulo 55 is 39. This one is 1, 23, 1. Okay, and you can do the exactly same thing for the decryption. Let me just quickly show. Okay, I think let's just take a very quick recap of what we already know. We have our prime numbers, prime fee number, encryption, decryption, private key, public key. So message seller, these our letters as numbers and our encrypted message. And this, let's take it, is how we got decrypted back, is our formula. Or there is also another formula that maybe you'll be familiar from the books, this one. But I just feel like encrypted D modulo N is a little more simpler. I should explain the book ones too. So where C is the encrypted number, D is 27 decryption number, modulo and number they were just counted. It's the same. So you're just based on the formula you calculated based on how we shown you for the modulo ones. And now we get the following. We get again 19, a 1, 1201. So that's how simple it is. Just remember on the exam you have to convert numbers back to letters and you will get something like this. Let's just continue on the next exercise here where again, just a quick recap, prime numbers P and Q 11, 5 and 11 and number is 55, our fee is 40, encryption number is 3, public key is as follows. To calculate private key we solved our equation and the private key now is DN 2755. And back again, here's a table letters in alphabet order with the numbers below. Our new encrypted message is 3901 49 20 5201. So given that D is 27, N is 55, and our encrypted message is 3901, etc. We will now decrypt each number. As we see, the first one is 39. What do we have to do? We have to put 39 up into the decryption number 27 modulo and number which is 55, so that we will end up with this one. Remainder will be 19 and 19 here is S. 1 is A, 12 is L, 1 is A, 13 is M, and 1 is A. Decrypted message will be Salama. That's it for today. Thank you for watching. See you in the next video. Bye.